Hi, I'm Colin. In this module, we're going to solve a particular inequality equation. We're going to find all the values of x, such that 4 onto minus x is less than or equal to 1. From the outset, it may seem like a good idea to do a little rearranging and multiply both sides by 2 minus x in order to bring this denominator to the right-hand side, which gives the following. Thereby giving us a simpler equation with no fractions. But unfortunately, it's not that simple here. That's because you must keep in mind a very important rule when solving inequality equations. When you're multiplying or dividing both sides of the equation by a negative number, you have to flip the inequality sign. And here, depending on what x is, the expression 2 minus x can either be positive or negative. So we must tread very carefully here. In fact, to solve this problem properly, we will need to methodically break it down into two separate cases. One where we assume that the denominator 2 minus x is positive, and the other where we assume that it's negative. So going back to what I wrote earlier, this equation is only true if the denominator 2 minus x is assumed to be positive. Otherwise, we would have to flip the inequality sign. So in the first case, let's assume that the denominator 2 minus x is positive, where we can then happily multiply both sides by the denominator and not have to worry about flipping the inequality sign. Do note that assuming 2 minus x is positive is the same as assuming that x is smaller than 2. Also note that x can't be 2 itself, since that would result in a zero denominator. Anyway, having moved 2 minus x to the right-hand side, we can rearrange for x as usual. So if we add x to both sides, we're going to get x plus 4 is less than or equal to 2. And now all I have to do is subtract off 4 from both sides. So I get x is less than or equal to negative 2. Notice that this satisfies the assumption we made earlier that x is smaller than 2. You must always check your obtained solutions against the assumptions that you made, because sometimes they won't automatically reconcile. Now, in case 2, we're going to assume that the denominator 2 minus x is instead negative. Importantly, observe that this happens when x is greater than 2. This time, when we multiply both sides by 2 minus x, we must flip the inequality sign from a less than or equal to a greater than or equal to. We then rearrange for x as usual, and we're going to employ some very similar maneuvers to last time. Firstly, we're going to add x to both sides, so we get x plus 4 once again, and this time it's greater than or equals to 2. And so subtracting our 4 from both sides, we now get x is greater than or equal to minus 2. Note that our answer for x doesn't fully satisfy the assumptions we made for this case, which is that x must be greater than 2. If we want x to be greater than negative 2 and greater than 2 at the same time, we simply need to take x is greater than 2. Now the full solution set for the equation are the solutions for the individual cases combined. Case 1 gave us the set of all the real numbers less than or equal to -2, which we can write as the following in interval notation. And case 2 gave us the set of all the real numbers greater than 2, which we can also write in interval notation. To combine these two disjoint intervals, we simply take their union. Alright, that's it. This question is not easy, and you should practice doing it again without watching the module. And make sure to practice on as many relevant problems as you can, and you'll become a pro at solving inequality equations in no time. Catch you next time.